Hello class, let's look at section 7.3 dealing with geometric sequences and series. So we did arithmetic, sequences and series. Now we'll look at geometric. So suppose I were to pay you 1 cent today, and then tomorrow I'll pay you 2 cents, 4 cents on the third day, 8 cents on the fourth day, and so on. How much would I pay you on the 20th day? So this is generating a sequence. So the first term of our sequence was 1 cent, and then 2 cents, 4, 8, and so on. I go all the way out to the 20th term of my sequence. But then second question, how much money would you have received altogether? So to determine that final amount of money, I would add up all of my terms of my sequence. Okay, so adding all those terms together, remember when we were working with an arithmetic sequence, when we add them up, that was called our series. Same thing with geometric. All right, so a geometric sequence is simply a sequence in which each term after the first is found by multiplying by the preceding term. And that multiple is going to be some fixed non-zero real number. So it can't be zero, and it's got to be a real number. It can't be a non-real number, non-zero real number. This is called the common ratio R. So that last slide where I was working in cents, let's just think of it as 1 cent, 2 cents, 4 cents, 8 cents, and so on. Just working in cents. So to get from here, I had to multiply by some common ratio R. To get from 2 to 4, I had to multiply by some common ratio R. From 4 to 8, multiply by some common ratio R. And we can start to see that that R, that multiple, had to have been 2. We're doubling every single time. Well, another way to find this, and we're going to get was more with other numbers that are a little bit harder to find just by looking at it, what that common ratio is. All we can do is take the term after another. So let's say I look at 4. So if I took 4 and I divided it by 2, so 4 divided by 2 got me my common ratio of 2. So instead of multiplying, I can think of dividing to undo it. By the same idea, I really had 2 times r equals 4. So therefore, r had to have been 4 divided by 2, which was 2. So instead of multiplying by r to get to 4 from 2, I'm going to divide by 2 to figure out what r is. So therefore, to find that common ratio, choose any term after the first and divide it by that preceding term. So if you look at a sequence, you're not sure right away what it's going to be because maybe it's the common ratio might be 3.75. Well, when there are decimal values like that, it makes it harder to recognize right away. Simply pick out 2 terms, take the term on the right, divide it by the term on the left. That will give you your common ratio. So if I had this sequence 2, 8, 32, 128, I could say, okay, well, to determine what my R is, I had to multiply by some R here. So really I had 2 times R equals 8. R would be 8 divided by 2, which was 4. And you might have been able to see that right away just by looking at it, that the common ratio was 4. But let's break this down a little bit more. Really, to get from my 8, for my 8, it was 2 times 4. That was simple enough. To get 32, well, that was really 8 times my common ratio of 4. But I can break this 8 down, and that's really 2 times 4 from our first line here. So this is really 2 times 4 times 4. Or I can think of this as 2 times 4 squared, because I have 2 4s I'm working with here. So that's 4 squared. That's not going to be, don't think of it as 2 times 4. That's 4 times 4, 4 squared. 4 times 4 is 16. 4 squared is 16. I could take this another step. Well, if I look at my 128, that's really 32 times 4. But I know my 32 here is the same as this, is the same as this. So I could say, well, that's 2 times 4 squared. times 4, which was 2 times 4 cubed now. So we're starting to see a little bit of a pattern where this was my second term, a sub 2. This was my third term, a sub 3. This was my fourth term, a sub 4 in my sequence. So to find any term in my sequence, I can use this pattern that I've just come up with. So to find any term in a geometric sequence where I know my first term is a sub 1, my common ratio is r, the nth term, so this a sub n, is given by the formula where I take my first term times my common ratio, so in this last one was 4, raised to the exponent of n minus 1. Okay, so going back to this one, my a sub 4, when I looked at this, I determined, well, my a sub n is a sub 1 times r raised to the n minus 1. My a sub 4 then would be my first term. My first term here was 2 times my r, which I found my r is 4. N is also 4 minus 1. So this is 2 times 4 cubed, which matches up to right with what we had here. All right, so this formula is what you need to use now for a geometric sequence. So getting back to this first problem, suppose I would pay you 1 cent and 2 cents, 4 cents and 8 cents. How much would I pay you on the 20th day? So we first have to establish what our R is going to be. In this case, it was doubling, so our common ratio R is 2. If I want to find on the 20th day, that would be a sub 20 is going to be my first term. So my first term was 1 cent times my common ratio, which is 2, raised to the n minus 1. Well, my n was 20 minus 1. So this is 0.01 times 2 raised to the 19th. If I work this all out, it would end up being $5,242.88. So we can see that number increases really quickly. So start out 1 cent the first day, all the way to the 20th day now. This is how much I would pay you on the 28th day. Now we can also find specific terms of a geometric sequence. So if I want to find the fifth term of the geometric sequence, 4, 12, 36, 108, so I'm trying to find this next term. What is a sub 5? Well, I know in a geometric sequence, there's multiplication simply by the preceding term. I can find my R to get from 4 to 12, I had to multiply by 3. From 12 to 36, I had to multiply by 3. 36 to 108, multiply by 3. So to get here, I had to multiply by 3. So a sub 5 is simply going to be 108 times 3, which ends up being 324. If I want to come up with just the general formula for this specific sequence, again, I found my R was going to be 3. So in general, any term, any nth term, is going to be that first term times R raised to the n minus 1. So in this case, if I want to find it for any of these, a sub n is going to be the first term, which is 4, times my R, which is 3, raised to the n minus 1. So that would be able to find any term in this sequence. And we could check our formula. So again, if I wanted to figure out what a sub 5 was, a sub 5 is going to be 4 times 3 raised to the 5 minus 1. So this is 4 times 3 to the 4th. And that does end up being 324. Let's do another example. Determine R and the first term if we're given that the third term is 20 and the sixth term is 160. All right. Well, I could work this out. I could say, well, if I'm at a sub 3 of 20, I'm going to have to multiply by r 3 times to get to a sub 6. So I'd add a3, a4, a5, a6. So I would have had 3 multiplications by r. Okay, and multiplying by r 3 times, that's going to be cubed. It's not going to be 3r, it's going to be r cubed. So in this case, a sub 6 is found by taking a sub 3 times r cubed. So we're not even going all the way back to a sub 1. I'm just going to work with my sequence from 3 to 6 because I know what those numbers are. 6 I know is 160. 3 I know is 20 times r cubed. Solve this, divide by 20, divide by 20. I end up with 8 equals r cubed. Cube root of 8 then would equal r. R would have to equal 2. So now I know exactly what r is going to be. Now, if I want to find out what a sub 1 is, I can go back to my formula where a sub n is going to be a sub 1 times r to the n minus 1. And I can just pick any value that I want. Well, I know a sub 3 is 20. So I'm going to say, well, a sub 3 is going to be equal to a sub 1 times my r, which I know my r is 2, to the n minus 1. So this would be 3 minus 1. Let's fill in some more numbers. I really know a sub 3 is 20. A sub 1 times 2 squared. And so this would be 20 divided by 2 squared, or 20 divided by 4, which is 5. So a sub 1 is 5. Now let's talk about the series. So a geometric series is just the sum of the terms of a geometric sequence. We're going to take all of those terms in our sequence, add them up, still it's sum, add them up, and that will give us our geometric series. We have a formula for this one. So this one's a little more involved. I'm not going through the proof on this one. I'll just give you the formula. So this series, so this notation with the S, all the way out to the nth term, is going to be the first term multiplied by 1 minus our common ratio r raised to the nth power, all divided by 1 minus r. So getting back to our very first example, pay you 1 cent, 2 cents, 4 cents, 8 cents. How much would I pay you on the 20th day? Well, we figured out on the 20th day, the amount I would pay you was that $5,242.88. But how much would you have received all together? So that's going to be the sum of all the money that I paid to you. And so this would be S sub 20. So I'm going out 20 terms. My first term was 1. Well, in this case, 1 cent. So let's go 0.01. 1 minus our R value, which doubled, so it was 2, raised to the n is just 20, and then 1 minus 2. Work all this out, ends up being $10,485.75. So over 20 days, starting out with a penny, doubling every day, you would end up with $10,485.75. So take a look at 7.3 in Math Excel. Do Sunday 5-3 by midnight. As always, I'm here to answer any questions, help you out in any way. Keep working through these Math Excel assignments.